We are talking about graphing general rational functions in different forms. And in some cases, if we expect there to be holes, we want to start with these steps here. So the first thing is we want to factor the numerator and the denominator fully. So I can rewrite this, and in the numerator here, I can see that each term has an x in it, so I can factor that out. So we can rewrite this as y equals x times x squared plus 5x plus 4. And then in the denominator, we can factor out a negative. We can factor out an x. And what we're left with then is x squared minus 4. From there, we can factor a little bit further. So we can say we still have the x out front. And two numbers that multiply together would be, to get to 4 would be 4 and 1, and they're both positive, so we can add those together. And in the denominator, we have x squared minus 4, so those are difference of squares. So we have x minus 2, x plus 2. So now we've rewritten the function a little bit, and we get to rewrite it a little bit further. So here we have an x in the denominator and an x in the numerator, so we can cancel those out. And that is going to end up being one of our holes, but I want to rewrite this one more time without those x's in it. So our new function is y equals x plus 1, x plus 4, divided by negative 1 times x minus 2, x plus 2. So from that information, we can calculate a few different things. So the next thing on the list, cancel any common terms, we did that. Any of the common terms that were canceled, you set it equal to 0, and those are the holes. So in this case, the ones that were canceled for the holes, that was just x equals 0. So you take what was canceled, set it equal to 0. You don't have any further algebra to do. So in this case, our hole is going to be at x equals 0. The next thing we can look at is we can look at our vertical asymptote. So our vertical asymptote, and we're going to calculate that the same way that we did before. We're going to set our denominator equal to 0. So then we can say 0 is equal to negative 1 times x minus 2 times x plus 2. And because this is in factored form already, I don't have to do any math. I know that if one of these parts is 0, the whole thing ends up being 0. So we have a vertical asymptote at x equals positive 2 and x equals negative 2. So we have 2, so I can write that in here. X equals negative 2 and x equals positive 2. So on our graph, we can sketch those. So that's negative 2. And then here we have positive 2. So our two vertical asymptotes, our horizontal asymptote. For that, we got to bring out our rule here. I guess before we do that, we have to figure out what everything is. So from our horizontal asymptote, in the numerator, this is going to be x squared, because x times x, the highest degree, is going to be x squared. And same thing in the denominator, that is also going to be x squared. So what that means is we have m is equal to 2 and n is equal to 2. So m is equal to n. So if we bring out our rules, so m is equal to n, that means that they have the same degree. So we make a fraction with the coefficients in front of the highest degree, and that ends up being our horizontal asymptote. So in this case, if we multiply x times x, we have 1. If we multiply x times x, and then we end up, and then multiply by -1, that ends up being -1. So y equals 1 over -1, which is equal to -1. So our horizontal asymptote is y equals -1. So we can sketch that as well. So we have this divided up quite a bit. And then the last thing that we can calculate is we can calculate our intercept. And in this case, it's already in factored form as well. So when we have the numerator is x plus 1, x plus 4, because it's in factored form already, we know that x is equal to -4 and -1. So -4, 0 is going to be right here, and -1, 0 is going to be right there. And I've already done some math for this to speed this process along a little bit. So we have -4, 0, we have -3 and 2/5. So -3 and 2/5 is going to be up here. -1, 0, 1 10/3, 1 10/3 is going to be up a little bit. So 1, 2, 3 and a third. 3, -5.6. 3, -5.6 is outside of our graph. And 4, this one is -10/3. And 4, -10/3. So 1, 2, 3 and a third, and we're right there. So this bottom section cuts this corner like this. This section over here drops down and cuts through here. And this one starts up, comes down, and actually is undefined at 1 or at 0. So that'll be undefined at x equals 0. And it actually goes down. Now here we do cross the asymptote, and it's okay to cross the asymptote when it is okay to cross the asymptote when it's around 0. The asymptote is the graph is not cross the asymptote when it either goes to negative infinity or positive infinity. And here's the graph, and we can see what it looks like. And then we also have that it is undefined at 0.